This code is sent to me by one of my students anonymously. Hello, Michael. And this code is a great opportunity to showcase 4 pillars of object-oriented programming: the encapsulation, abstraction, inheritance, and polymorphism on one real-life project, real-life source code. If you're struggling to migrate from procedural code to object-oriented code, then this video is perfect for you. This project actually works fine in real life. It's actually quite successful with a lot of users, bringing our anonymous student Michael a very decent income. Just proves that the code complexity has nothing to do with the real-life problem that one project can solve. But this code, as it is preventing the project to grow, and that is where object-oriented approach could help us. So let's refactor it a bit and see how it could be improved. So here I have some home.php, which I assume is some sort of a dashboard listing all kinds of statistics from the database. We will just look at the source code here, and here we can see that there is some client profile, book appointment, some top product, balance and sales, etc. And it also, this file starts with one mfile.php, which is difficult to tell what it is by name, but if I open mfile.php, we see that there is some connection there, some privileges checking from the database by the user, also checking the SMS ID and the main setup and things like that. And this is similar code to what I was introduced when I started programming in my first company about 17 years ago, and it's a typical query to HTML code where we basically select some data from the database, right? We put it in one variable and then immediately we just dump it out to the user with some HTML code. And every time I would have to change something in the code or database, I would have nightmares over what I have forgotten on some of the pages because this code is so scattered. It's fine when you are looking at one file, but this project has a lot of files here in the listing, and each of those files might refer to the client profile or the book appointment or the product database. And this way of writing code where we have one query and then one for each just here in the loop and maybe some if-else here and there, we can be rude and say that this is almost no programming here. Database tables are just dumped to the HTML as tables again. But again, this project is doing just fine. Financially, it is solving the problem clients need. So what is the problem then if it's working great? Well, once the project reaches its critical user mass and more programmers are needed to maintain this, to add more functionality or to maintain the existing functionality, to change something, it soon becomes painfully expensive to expand this project, to work on it, and the project might even fail under its own weight because it became a bit complex. But also Michael has been working with PHP for about 5 years and now wants to improve and learn new techniques to improve this project, but also to find a job as an expert in some company because he has a lot of real-life experience with the project, a lot of users, and a lot of years of working. So Michael started learning some frameworks to master all those fancy words like services, facades, containers, design patterns, etc. But the problem is that going from writing code that is like this, directly to dumping data to the HTML, and stepping up to the, say, Laravel, for example, is that one needs to learn programming along the way. And I will probably sound very harsh to this code, but I want to help Michael improve. This project has enormous potential, but it could be limited by its architecture, or the lack of it. And Michael could be limited by his experience. Despite of working as programmer for 5 years, with this level of knowledge, it will be challenging to find some senior position, especially where it's expected to lead other junior programmers and work more on the architecture. So let's discuss objects. There could be a lot of things improved. Today we will discuss objects. And when we use objects in some code, if we replace this code with objects, the objects give us a lot of mechanisms that we can benefit on multiple levels and some advantages, like being useful on complex problems because you can split complex problems in smaller parts and you simplify the problems and thus solve them on a bit more granular level. It also groups some relevant codes, it encapsulates it in some other portions. We will talk about encapsulation very soon. Objects also help us debugging because we can isolate code, and they are usually easier for automated testing and are widely used and wanted in the industry, so you can find a job as an object-oriented programmer. They're not a magic pill and it doesn't solve all the problems that we might encounter. But today, as mentioned, 4 pillars of object-oriented programming, and those are encapsulation, abstraction, inheritance, and polymorphism. The encapsulation solves the problem of scattered code and unorganized code by closing all relevant functionality in one capsule like. We'll go over each of these in more details as we refactor the code, as well as show some code examples for each of them. The abstraction is useful to simplify usage of our classes and our objects by abstracting some functionality away. This improves code readability and stability of the code, as we have less things to think about implementation, and we can focus on the business logic. Inheritance, it allows for children to inherit some functionality in form of methods and properties from their parents, and it can also add things to do what they have inherited. And this also helps with code reusability, where similar classes and objects can use exactly the same functionality from their parents. And finally, we will see how objects can be morphed into some other objects by changing some behavior or some property, and that is where polymorphism comes into the play. So if we look at our code, the first obvious thing to discuss is encapsulation. I have found one pos.php file here because it is mainly oriented to working with some products. It has a lot of selects from the product, top product, and TP product, etc. And one of the problems is that this code is sort of all over the place. There could be some code working here, and if we would to change the product database or some other property, we would have to change pretty much every file, and we would struggle a lot with finding, say, TP month or the value here, because if T value is universal property name for all the other databases, we cannot just find and replace. And if we are ever struggling to refactor our code, we are struggling to improve and change our project, and that is never a good thing. So as mentioned, encapsulation is just a fancy name for organizing the code into separate chunks into one capsules, meaning splitting and grouping the code in small portions. And one object here would be a database manipulation, and then we would have another object that would be checking the privileges, for example, and another that will work with products, yet another object that is working with sales, and thus group that code, encapsulate it into multiple capsules. And then at the end we will have one object that will be in charge of presenting that view to the customer. And your first question might be, why would I create so many objects and so many files when it's much simpler to have this query be here as it is, and we can immediately see what it does, and we can just follow it down in the HTML and see where it's being outputted to the user. And the object-oriented programming is just complicating things way too much. And you would be correct for this particular file. However, this application, as mentioned, is a huge application having a bunch of files where finding all those changes is very difficult, not feasible, not that easy to do. With a lot of individual files like this, we basically do not have one application. We have a lot of individual web pages that looks the same and perhaps share some configuration. But this is not one application that we have control of it. It's a lot of individual pages in one folder that sort of look the same. And in each of those files, there could be some code or some query working with products, and there is no way of knowing that. We cannot change database if needed. We cannot add easily new fields, or rename the existing fields, remove something without searching and changing a bunch of files, and testing all that is just very difficult. That is where encapsulation helps us. It is enclosing all the code that has with product to do in one capsule, both database code but also different logic that might manipulate product data, that might reformat that data. So that would be one thing that will make it easy to maintain our code, because that way we immediately know where to find anything that is product related. Properties and methods would sort of be our variables and functions, but only for that specific context, only for that capsule. And you can think of it as making multiple small projects, each in its own world, that can also communicate with other small projects, but each has a specific purpose and a specific role in the whole picture. Again, encapsulation is relevant for both methods and properties to do some operation. Let's make one product capsule by making one product class. So here I will just make one folder named models, and inside I will make one class called product.php. Now there are bazillion ways of organizing this code and going deep into design patterns and all other principles, but let's focus on encapsulation for now. Now this product object here will be one and only one place where the code that has anything with products will live in. So let's move some code from home into the product view, and I will open this so that we can see both of those, how it looks like in real life. So here in POS, I will move this select logic and this update logic to the products. So for example, this select we could move into one property, one method call it select, because I'm that creative. And we would just move this code from here into our newly created property, newly created object, where we would have a query, right? And we would then, instead of just doing it here, we will just return this query, and this die is not relevant here. We will go away from that. And in order to use our new product object and a class, we will just have one product here equals to new product. Of course, we would need to include this product file. We can do that at the beginning, or we can have some global include. So I will just comment it here because we are not going to run this code. We're just discussing principles. And then this product would return this select. Now we see that this select is having some properties here, so we can just put them here at the top because we are going to pass them down to this method one by one. They could also have the default value, which is something that we could not do from before. We can just put the default value to each of those. And then this is the same. Now these two lines of code replace this query here in line. And here we see that there is one SQL for insert, and that would be our new property, insert, where we would basically just move all of this inside. Instead of putting it here, we will return it. And again, we are not going to handle errors here. Errors could be handled globally, or we could have an object that's handling the errors. For now, let's just show how this would work. Then we will going to have the result top insert, where product would have the insert. Again, same things with these values. We can provide them inside. In this case, they will not be empty because we assume that we want to insert something into the database. But these values will be provided from here, as well as these select values, which I forgot to provide from here. We will just pass them to our newly created newly created methods. Now this, you can argue, looks much better than this because we have just one line for select and one for insert. We can even read this over here in plain English. We see that we are selecting, we see that we are inserting some data. We don't need to each time read the actual query to understand what's going on. And now the fun part, if this file or this project or pretty much anything else has any interaction with products here, with top product, if we would to find in files, we can see that there is a lot of usages in pretty much a lot of files for this top product, not just the update as well, but the select and insert. It's used in all different files from here. Now, in each of those different files, we could just put one line of code that will replace our code and work from this main object here. If we look at the home, for example, we have this select over here as well, where we can just, again, do the same thing, replace this code with our product code here from the pos.php, and we can see that this code has a bit different logic. It has some empty values. It doesn't have all the properties, all the values that we are passing in, which is great because we have defaults for those. And this is how we would have centralized place where we would select the products based on this code here. Now, obviously here, this where would need to be refactored a bit. So we would have to, let me just close this one. We would have to make one, say SQL where string, where we would go over each of those properties and see which one is set. And then if the p size is set, we would then check if it's not empty, right? And then we would extend this string and just make it a bit more dynamic, where we could say that SQL where string is empty string to begin with. And then we would add more things to it, like this, what was it, size, yes. And we would put this and size to the string, where we would at the end just append this string. Now we will do this for each of those properties, like a quick and dirty fix, but that way we could just pass individual properties and our function will then automatically know how to make this string for us, how to make this SQL query. Of course, this is not the best way to pass variables, but that's not the point here. The same thing for insert, where we could sometimes insert a bit more. Somewhere down the code, we might have a insert of some other properties. So we would make these properties, this query, dynamic. And now you can see how it would be useful if we would to change, for example, this field in database from TP size to just size, for example, or something else. We would not have to change anything in the code here because this select does not know about database. It does not know how to work with queries because all the queries code, all the product database code, all the code that has with product to do is encapsulated in one centralized place here inside of our product module, right? Our product object, sorry. And the same thing for insert. If we would go here to our insert here, we see that it's doing the same thing. And we also see that we have this update product, which is exactly the same thing. If I would just speed up and do this very fast with the update, we have some properties that we are going to pass inside this method. And here we would then use our new object with the update. And we would pass it the properties that it needs to work with. So now that's even easier. We have one select here, which is basically the same logic as we would do with this select from here. We would just pass some different values and we would put some if else's here to select us the proper code, proper data from the database. Now here we can see that how easier it is to just select some data from the product. If it exists or if it's less than one, we would insert one. If not, we will select the other one. And we would then just update the results. Now that is much easier to read because we can read it in plain English. We are selecting, inserting, selecting again, and then updating. We have abstracted now how this works, how this object works internally, how these products behave from the perspective of the object user. So this is our object consumer. It's just consuming our methods. It doesn't care what the select, insert, and update does. We just ask our objects to get us the proper values, to do something, and we do not care what it's going to do, which table is there, if it's going to maybe cache some mechanism, if it's going to database at all, if it will parse some file, whatever. It's just abstracted from us, and we don't care when we are working with the business logic, when we are focusing whether we should select, check, count, and do something. We don't want to be thinking in the database terms and complicate our lives unnecessarily. And one more thing that our products could have, they could have some private properties here, say database name, which are not available from the users from here, because this controller here, this logic here does not need to know the database name for the project. It just needs the project, it just needs the data. There we could do some calculation here and store it locally and have also some methods that are not available for the outside use. And that is basically what abstraction is all about. By just moving internal workings outside of the object consumer, our controllers, we have achieved the abstraction, meaning consumers of our product class or user class in this presentation here, our consumers do not know how the objects work internally, what functionality they have internally. All that is abstracted from them. And the less variables we have to work with while we are consuming our objects and our code, the easier and more robust the code is. We would have private and public access to some of the methods and some of the properties, and we usually use the private and public modifiers, which help us with abstraction, but they're not necessary for the concept itself. And again, this code here, it's much easier to read because we have it in plain English again. Select, insert, update, there is nothing magical here. And the whole point is that our server does not care what we write. Both of these code work, both the old one, the old code that we have here, it will work just fine, and this code here will work just fine. Our server does not care, but our colleagues and our future self, we care. That's why we always want to optimize our code for reading. We understand what this SQL does, and it's fine when we are working with this code. You get into the mentality of understanding what you're actually doing, and you just go and do it. But the less thing we have to guess, we have to read, the easier maintenance is. And sure, all this can be done nicely with functions as well. But the object-oriented style is generally more robust with all these concepts, especially the things that we are going to talk now. You might think that, of course, you're going to read your code, you work alone on your project anyway, so you know what you're writing here, right? That's great if you're the one single person working on a hobby project. But the goal of each project and each company is to grow, to have more people and more users, and sooner or later you will need help maintaining this project. And when you get a new developer, he will now need to use way more code, way more time to figure out what this code does and how it works. It might be even impossible for a new developer to figure this out. So every change will be very expensive, and you will soon want to create project entirely from scratch using some framework or existing library or something. That's just not practical at all. It's much better to have a good code in the first place, right? And I worked on projects coded like this, and I know about the meetings where investors were discussing several millions for the projects because there is a huge user base. But when they read the report from the code review, they were straight up screaming in disappointment and rage, because they had no possibility to improve project in its current state. So they reduced the price in more than half, because everything would need to be written from scratch. So investors basically ended up buying for the user base and then migrate them to some other project. The project itself, it was not useful to anybody but the original developer who made it. And you do not want to be in the situation when somebody tells you that your project is useless because you are the only person who understands how it works. No one benefits from that, not even you. So let's continue with this code. And here on POS file, we have this select from client profile. And then we also have some insert into client profile, as well as select again from client profile. Now this obviously we could refactor this to be something like client profile is new client profile. That is, you guessed it, the object that we are going to make, and then this client profile would have some method like, well, select. And then here we would have, you guessed it, one client profile insert, where we will just comment this one for now and have the result for the insert being returned by insert. So this would be insert, right? And again, we would have one select with the result profile this time. And if I were to make quickly one client profile here inside the models, that class would pretty soon become same, if not identical, as the products here, because we have select, insert, and update, right? Similar functionality. This select would be basically same as here. So the function select. And the only parameter would be this count. I guess it's count or maybe not. The insert would then be this functionality here, where we would just return it. And if we now look at this product and this client, we can see that they look pretty much the same. They have the insert, select, and update. Both are doing some queries. And you can say, why should we need the project or the objects for this? We could just use plain old functions, right? And you would actually be right. So far, so good. We can just make some functions for the product and the client, something like select from product, insert into product, and update into product, then select from client, insert into client, etc., etc. The only thing is, because we have so many entities, we would have the same number of functions, which would get, say, to 20 functions, for example. However, with functions, we would still not have a very reasonable and good encapsulation, because they have the same name. Here, select is the same, insert is the same in both product and client profile. So we know that select and insert and update on a product object is encapsulated into that capsule. That's where objects help us with that. And we will basically never have the option to do that with functions, because the names had to be unique for each and every function. But even more than that, since we have two objects that are pretty much the same, even if identical, we could say, we could maybe summarize these methods into one main method that both can share. And to do that, we can use the inheritance to our advantage. That is one of the tools that object-oriented code has, which is pretty much unavailable in other coding styles. The inheritance basically allows us to, well, inherit some functionality from what we call the parent objects, so that their children can use that functionality as well. One object, or one class rather, would have some properties and some methods. Say in some controller we could have run action and render view and something like that, and our children will be able to maybe change some functionality, like this property here is Ajax, and they could add additional methods like show page, and then change some, again, functionality, or even add more additional properties, and even overwrite some of the existing properties and methods. That way, when the code actually runs and we are using one of the children objects, it will look as if that object has all the functionality from their parent, but also additional functionality that they might have added on their own or changed on their own. That is basically what inheritance is, meaning that our objects can reuse some functionality from their parent objects. Does this explanation make any sense? A lot of students ask me about migrating from procedural to object-oriented programming, so if there is something that you are struggling with when it comes to working with objects, please write me a comment, as I might create a full course about it and I can give you some more information. So here we would make one object, let's say a parent object. We can call it, say, a base module or base model, because I'm that creative. And inside of it, we are going to make one class, a name base model, that will contain all the functionality that we should share between our children objects. Like in our example, we can have this select and insert and update that I'm going to basically move to this base model. And we notice here that the fields are hard-coded, but as well as the table name. The top product here is hard-coded. If we are going to share this base model from the product and client profile, that will not work because the client profile is a different table, right? But what we can do is we can use other elements of objects, and we can have one private property named table name. And that table name could be used, well, instead of this table name here, right? We can just append it by saying this table name. We would do the same for the insert and the same for update here. Then each method would use this property instead of the table name, which means that it's dynamic. Now inside of our product, we can basically inherit or extend base model, which again needs to be included and everything like that. But our product would then get all these methods for free. It will just work. If I were to check here somewhere where we have the product here, I can just type product, and even my editor will understand that the product now has these properties because it inherited it by extending the base model over here. The cool thing is that the client profile can also extend the base model. So then we don't need this select and insert anymore. We do, however, need to overwrite this table name, which is not supposed to be private. It could be protected, but we can just say protected table name, and we can just overwrite it with the what we had here, client profile here, and this product will have the exact same change for the table name field, except that it will be a top product, right? Probably this is a top product, not a regular product, but the point is the same. And now our client profile here, if I would to try to call the client profile methods, our editor will actually offer us the update insert select functionality because the client profile extends the base model the same way as our product, which means that both objects are now, both the product and client profile, they have zero code in them. They're just configuring the base model that it's working with. And obviously these queries have some fields hard-coded here, but this is something that we could make a dynamic here. We could make one array here, name table fields, which will contain all of the fields that this object will use. In this case, this will be empty, but in our client config, for example, we could configure all the fields like, I don't know, the client ID or CLID, then client last name, etc., etc. And then we could maybe just loop over all the table fields here and dynamically create the select part or the insert part, where we could just use these properties from each object that is inheriting the base model. That is basically how active record design pattern works. But another cool thing is that we could here just make a new, if we need to change some functionality on a very deeper level, we could just make a new method with the same name as the parent method, the insert, and we could just, not the insert, the insert, and we could just write some new code here that will overwrite everything that's here in the base model, meaning that in some case, if we need to have some select or some insert or something different, not this insert here, but we need something entirely completely different, we could just override this method here the same way as we have overwritten this property here, thus making this product, which inherits as some parts of the base model, a completely different object that will suit our needs much better. Sometimes we cannot just we cannot reuse universal code for something, we just overwrite it from here and we put some entirely custom code. So by changing some of the properties and some of the methods, overwriting them or maybe configuring them differently, we can basically make one base model be product, client profile, or report, or database admin, or manager, or order, or whatever, which in essence makes it possible to reuse one product as something entirely different. And that is the polymorphism in the nutshell. Now, polymorphism took me some time to understand it, and I'm still working with it, probably because I'm not that smart guy, but also it sounds a bit complicated than it might really be. It is usually related to inheritance, and it is used in the similar fashion, especially in PHP. And that used to confuse me a bit before I started working with some other programming languages, but in essence, polymorphism allows us to have some class that has some functionality and allows us to have it morphed to some other class. Say that we have this product, for example, with its name and is shippable properties and some methods like calculate shipping, for example. By extending that or inheriting that object, we could change some values that it has, like this is shippable to 0, and maybe even overwrite this calculate shipping and making some different logic for it, or saying that shipping is always 0, right? We can make this product be digital product suddenly. It might have some different functionality. Or say that we inherit it and then we change this is shippable to 1. And maybe even providing some different calculate shipping method, we can suddenly have a physical version of this product. So this product will then be a physical product, this one will be digital. They will be similar when it comes to other functionality, the name and maybe some other methods, but in essence they're different products. And that allows us to morph our product into something completely different, into something entirely new that we can use in some different context and in some different scenarios. Or in our case, it can allow us to use some object in some different scenarios with some different database fields and have them do some completely different things. Here we could have a product, for example, we could have calculate shipping and this method that will do something with the shipping that client profile might not have to do, because why should it? That way our base model becomes the product, it morphs itself into something different. As I mentioned, if I would to make this code completely functional, to run it basically, I would make entire active record pattern and a library, and that takes some time to cover all the cases. But I do have entire YouTube series on how to make one active record and how it works with all the elements that are needed, so check the link in the description here in the tab. But in essence, our code would even build this entire query, this portion, the select and all this update. It will do some fancy auto-completion of of tables based on the product name or the object name, etc., etc., because this object has all that information here available and all this configuration here, so it can do really a lot with it. It can morph and become pretty much any other object that we need. So imagine if we have 20 different objects like users, user groups, or sales or products, etc. They would all reuse that code that we had, and it would be very easy and clear to work with them. We just extend the base model and we just change some of the parameters here. And it is very clear what it does inside of our controller. We can just see that it is selecting something or inserting some data into database and whatever it's done. So the obvious advantage is that the code is now more centralized, and if we need to change one method, we firstly know exactly where to find it, and secondly, our fix would be available to all the children of this object. If we fix select or insert or something like that, it's available throughout our application. So let's see what more we can improve with this code. But let's quickly summarize our pillars of object-oriented code first. We know now that the encapsulation means that the code is enclosed in one logical unit. This could be one class or even a set of classes, but the point is that if we work with products or shopping cart, we pretty much immediately know where to find the code for that specific functionality we're interested in. We know that the abstraction is referred to, say, hiding or usually simplifying some functionality by hiding it from the users, from the end user, abstracting it from the end user of our object or our library. For example, PHP itself is abstraction of C and some C++ code, which is abstraction of more basic languages like machine code, which is zeros and ones, which PC understands. But in PHP, we do not care how it works under the hood. We just want to, say, send an email. Then we just use email function and the rest is hidden from us, it's abstracted. We have also seen how inheritance allows us to, well, inherit some functionality from the parent objects. In object-oriented terms, we usually speak of parent classes who have some functionality that their children inherit and reuse. For example, we might have some class like basic log or product, for example, and then this log might have some methods like info, warning, and error, and our children would then inherit that class and have some functionality of their own, or maybe extend some functionality, say like have something like format date, which could append current timestamps to logs, and our logs would then have both parents functionality and its own functionality at the same time. And finally, we have seen how polymorphism allows us to morph some objects into some other objects by changing some behavior or some property. This helps tremendously with code reusability, as our products can become both digital products that could be immediately downloaded without any shipping costs, or the products can become a physical product that needs to be shipped manually and there is some cost involved with that process, time delay, etc. etc. Or in our case of models, one model can become different database entity, which is what Object Relation Mapper, or more specifically Active Record, does in essence. Now there is a lot to be discussed here about code security and good practices and query injection and everything, but let us focus on the architecture first. With this code, I would actually suggest to migrating this code structure, this list of files, to the model view controller or MVC approach, because it fits nicely with this project. One of the problems MVC tries to solve is separation of concern between interaction with database, our models, the presentation of data, our views, and the control of the data flow, or our controllers. Here in this home PHP, we can see that the model is the same file as this view, this presentational part, because here we read some data from the database, we then manipulate that data, we change it, do something with it, and then we just dump it down to the browser here in the side of this HTML, this view. And this would be our model here at the beginning, and this will be our view here in the end. And the controller is basically not existing, but linking between these files, that would be our controller. But the controllers would delegate in an MVC, they would delegate which data should be gathered for some specific view. And that would clean up all these files and give us one single entry point to our application. So if we would put one index.php file here in the root, inside we would route our traffic to different controllers, which are usually corresponding to different pages, but also parts of the pages. And that way of working is incidentally called front controller design pattern, where we would have control over all possible pages in one single file, one entry point, right? One front controller. That way we can, for example, take down the entire application if needed, change themes or change some common code, reuse more of the code because we have it all in one place. It's reused for all the code. Right now here, if we would to have some config, some global configuration, it would be very difficult. We would have to go and include it all the places and extend it and everything. So this code is unique for all the pages. It could be extracted to one page, right? And our models, they would be in charge of this manipulation of data with all those queries here and all this logic that is there. And finally, views would just format and present that information to users, and even views can be organized a bit more so that it's easier to change, easier to give to a designer, for example, make a new theme for the website, etc., modernize it, etc. So if you're on the same place as Michael, this should be enough to prepare you for the journey towards mastering the object-oriented programming and get your skills to an upper level. MVC and objects in general are almost standard these days. because most popular frameworks and applications use it with a good reason, and we as applicable programmers should know how to use them and when to use them, even if we might not like it for some project. Writing software is a craft that should always be improved. Of course, there is much more to this code, as I mentioned, but if you want to learn more about object-oriented programming, check my free course on how to build one CMS from scratch using objects, model view controller, active record, and more. Here is a joke for you.